Hey, what's going on, guys? Let's try this problem right here. Here this question is asking to find the limit of this vector function. Now let's see how we can do this. Here all we have to do is find the limit of each of this expression individually. Like we take the limit t approaches infinity of sine t over t in the I direction, right? And the next one is going to be t plus 1 over 3t plus 4 in the j direction, and this one we can rewrite it as 2 ln t, right? Because when we have square we can move it to the front, so this is going to be 2 ln t. So when you have any power you can move it to the front, right? So 2 ln t, and this is going to be 2 cube, t cube in the k direction. Now let's see how we can find each of this limit. Now let's rewrite this one as limit t approaches infinity of sine t over t in the I direction plus limit t approaches infinity t plus 1 over 3t plus 4 in the j direction, right? J direction. And the next one is going to be limit t approaches infinity 2 ln t over t cube in the k direction. Now let's see how we can find each limit. First one, if you look at this, that's sine t over t, right? And if you apply this infinity for this one, sine infinity does not exist, and over infinity, so it's gonna make this one something does not undefined, right? So here what we have to do is, when you have sine function or cos function, you can do the L'Hopital rule. Here that's what we are going to do, and we know that sine of any value is going to be between -1 and +1, right? So if this is true, then sine t over t is going to be between -1 over t and +1 over t. Now what we are going, so if this is true, then limit of this limit t approaches infinity of sine t over t, sine t over t should be between limit t approaches infinity of -1 over t and limit t approaches infinity of +1 over t, right? And from this one we already know this is going to be 0, because -1 over infinity, that's going to make this one 0, and 1 over infinity, this is also going to be 0. Therefore this limit t approaches infinity sine t over t is going to be between 0 and also 0. So if this is between 0 and 0, this one also must be a 0, right? So this also a 0. So from this one we know that limit of this one is going to be 0. So we have solved the first one. So this is 0i, and the next one is going to be limit t approaches infinity t plus 1 over 3t plus 4. If you substitute infinity, that's going to be infinity over infinity. So you can do the L'Hopital rule for this one, but the easiest method here is when you have same power. Like here we have t power 1, right? The coefficients of this leading power is going to be the limit. Here we have 1 in front of this t, right? When we have nothing, it's 1, and in the bottom one we have 3. So 1 over 3 is going to be the limit of this one. So we don't have to go and do L'Hopital rule. We can easily find out by the coefficients. And the next one we have 2 ln t cube. Again, this is going to be infinity over infinity if you substitute this one. So here we have to do the L'Hopital rule, right? Let's do the L'Hopital rule. L'Hopital rule is we take the derivative, t approaches infinity, and first if you take the derivative of the top one, that's going to give us 2 times, let's avoid x sign, 2 times 1 over t, right? Because derivative of ln t is going to be 1 over t, right? And in the bottom we are going to have 3t square, right? If you take the derivative, that's going to give us 3t square. Now we have this one, we can rewrite this one as limit t approaches infinity 2 over 3 times 1 over t cube. And now if you substitute this infinity, this is going to make this one 0, right? Because 1 over infinity, that's going to be 0. 0 multiplied by any number is going to be 0. Therefore, this one is going to be 0. So this limit is 0, right? So we can express our final answer as this 0 I direction plus 1 over 3 in the j direction plus 0 in the k direction, right? 0 in the k direction. Also we can write this one as 0 comma 1 over 3 comma 0. So this is going to be our final answer. This is going to be the limit of this vector function. I hope you guys find this video helpful. See you next time.